Hi guys, today we're going to talk about KPI optimization basics. I have received a lots of requests asking about KPI optimization and to start it from the scratch in a step-by-step approach. So today that's what we're going to do. What I've done here is that I have introduced a concept about KPI optimization matrix. So what it means is that we'll talk about a KPI. We'll look at how we can identify different issues from the KPIs, and then I will tell you step-by-step approach how we can solve each issue. So let's have a look at it and see what we can learn from that. So if we take an issue which is one of the most common issues and one of the most required skill set is to identify low throughput issues. What are the causes for low throughput and how we can rectify that. Now this applies to both 5G and 4G. You have 5G NR, you have 4G LTE, it's SA, NSA, whatever it is. More or less the main concept when it comes to the optimization matrix is pretty similar. So mainly we have 4 major causes here. The first one is poor coverage. Now that is a pretty straightforward one. So which KPIs you should look at? So if you have high TA, now what is TA? TA is the timing advance. Now if you have high TA, that means users are far away from the cell. Similarly, you will also have high path loss. So the counters showing path loss will show that users are very far away from the cell. So if you have high TA and high path loss, then it means the users are at cell edge, and correspondingly you will also have lower MCS. What is MCS? That is modulation and coding scheme. So that is something like 16 QAM, QPSK. So if you have high tendency of QPSK with higher TA and higher path loss, that would indicate a coverage issue. So your throughput is impacted because of users that are in poor coverage. Now what can we do with them? How can we solve that? For this one, look at the cells which are bad with these kind of signatures. You can increase their tilt, I mean you can up tilt them so that they can cover further. You can increase their power so that their coverage increases. If you see that on the map, you can see that if the users are somewhere in a blind spot, you can even retune the azimuths to cover that area. That will also improve this kind of scenario. Or if everything else is done and you're still unable to tackle this poor coverage issue, then you can also suggest a new site or a cell. But this one was a pretty simple one. Another issue would be an interference issue. Now what will be an interference issue? So in that case, what will happen is that your TA will not be high, it will be like low or medium. That means the users are not very far away. Similarly, the path loss will be low or medium, not high. That again means users are not very far away as long as the distance is concerned. Now the next one would be that you will have low MCS, but you will also have a low CQI. So what it means, what is CQI? CQI is channel quality indicator. Now what is a low CQI? Let's say something below 8 is, you can say that you are starting to have higher interference. So if you have a lower CQI and a lower MCS, but your TA and path loss stats show that the users are not very far away, that would indicate more of an interference limited scenario. Or what is interference limited? That means your users will be having a lower SINR, which will be causing lower throughputs. Now what can we do with them? Now with lower SINR or high interference, we can actually go for down tilts. So if you do down tilt, what happens is that the area where more cells are overlapping will reduce. That will bring down your interference and it will improve your CQI, it will improve your MCS, and overall your throughput will improve as well. Another issue, another mitigation factor resolution can be power reductions. If you reduce the power, that can also improve your RSSI and also reduce the interference. For instance, in case of LTE, for instance, you have the CRS power, which is the power of the reference signal. Now if the reference signals are boosted, in that case you will have higher interference from the reference signals. So in this kind of scenario where you have interference limitation, if you deboost your reference signals, that can help in reducing the interference and improving the overall channel quality and throughput. Another aspect would be the interference mitigation features. Now what are these? These are the features which actually can reduce interference. For instance, you have downlink, uplink, coordinated multipoint, also known as comp. You have supercells, you have SFN, ASFN type of features. Now what do they do? In simple words, they can put two cells and make it into one cell. So for instance, where is interference? Interference is in the area where two cells are overlapping. So those areas where two cells are overlapping, they interfere with each other, right? But if in those areas both of those cells become one cell, then what happens? Interference finishes, because now at that point where they were previously working as two individual cells interfering with one another, and now they have become one cell at that point. So when both of them are transmitting the same data to that UE, what will happen is the interference will go down. Of course, it increases the overhead. That is why now the features have kind of dynamic or adaptiveness to it, that these cells only become a single cell at particular locations when the interference is high. Otherwise they work as individual cells. So these kind of features can really improve your interference scenarios. Now the next one could be congestion scenario. Now congestion can be on the data channel or it can be on the control channel. First of all, let's look at the data channel. Now in case of a data congestion, and if your limitation is congestion, you will see that your MCS and CQI are good. They are not a problem, but you have very high PRB utilization. What is PRB? PRB is physical resource block. Now all of these are actual counters or KPIs, so you don't need any other information to find out these problems. So over here we're talking about the KPIs or counters which can show you the indication, or which can be used for identification of the issue, while here we have the actions. So for data congestion, you will see that the MCS and CQI, they are okay or medium or even good, but you have very high PRB utilization. Now it could also be said that, let's say I have low MCS, low CQI and high PRB utilization. So what is it? Is it interference scenario or is it data congestion? If you have low MCS and low CQI and still you have high PRB utilization, then you will still consider it as an interference scenario. Why is that? Because if you have low MCS, let's say QPSK, then what happens is that a low modulation scheme uses high number of resource blocks. So your congestion that you have in case of this low MCS and low CQI is because of interference. If you remove the interference with these actions, MCS will increase, CQI will increase, then you might be using 64 QAM or 256 QAM as a modulation. That will use much lesser resource blocks and your congestion will also go away. But if you still have high MCS and high CQI, but you also have high resource block utilization, then you fall in the category of data congestion. Now in that case, what actions you can take? Now the first one is a pretty simple one. You go for load balancing. So what is load balancing? If you have, let's say, multiple carriers, you have let's say 2600 carrier, 2100, 1800, 900, 800. So if you have high congestion on 1800, you can trigger load balancing to move users away from 1800 to another carrier which is not congested. In that case, you will reduce the load on 1800 and you will improve the throughput of the users, and you will have a better balancing of the traffic as well. Another one could be traffic steering. You can make, let's say you have a scenario where you have a high congestion on 1800 and you want to shift traffic to another carrier. You can either use idle mode mobility strategy, that I already have covered these in other videos, but what it means is that you can give a higher priority to another carrier, and then the users will be shifted to that carrier. Similarly, you can do it in connected mode as well, using either priority based, service based handovers, or there are multiple ways to do that. So you can try that as well. Another option, if you have done everything and nothing else is able to resolve the issue, then you can recommend additional cell or additional site to take the traffic, to offload the traffic and to relieve the congestion. Now let's move to the next one, which is the control channel congestion. Now what is this and why it impacts? If you have, let's say, a control channel congestion, what will happen is that you will see that MCS and CQI are not really a problem, and your PRB utilization is also not very high, but you will have a very high PDCCH utilization, or you will also see that you will have very high PDCCH blocking. So what it means is that the amount of data you have to send, it is getting limited because of the control channel. Now how does the control channel and data channel work? The user reads the PDCCH, which is the control channel, and the PDCCH then tells the user where the data is located on the PDSCH, where the PRBs are. Okay, so if your PDCCH is fully congested, then what will happen is that the users all the users will not be able to be scheduled in that TTI. Let's take an example. If you have, let's say, 10 users, and your PDCCH congestion happens with 6 users already, then the remaining 4 users will not be able to get their scheduling or their data in that subframe or in that slot. So in turn, it will happen is that PDCCH will be fully congested by those 6 users, but because the PRB were still there, so the PRB utilization will be still lower. So you still have data capacity, but your control capacity has already exceeded your PDCCH symbol capacity or CCE capacity. Now what can we do about it? The first thing could be to look into the PDCCH link adaptation optimization. Now what is link adaptation? What is over here I refer to LA. Now in PDCCH we have a structure which is made up of CCEs. Now each PDCCH can be 1 CC, it can be 2 CCs. If users are in medium radio conditions, it can be 4 CCs. If users are in bad radio conditions, it can be 8 CCs or 16 CCs. Now the more CCEs the PDCCH uses, that means it eats up more resources and you can have a higher PDCCH congestion. Now in LTE we have 1, 2, 4 and 8 CCs. In 5G we also have 1, 2, 4 and 8, plus we have 16 CCs as well. Now if you have higher PDCCH utilization, to relieve that, you can make your PDCCH link adaptation algorithm a bit aggressive, so that the users that were getting 16 CCs before start getting 8 CCs. Users that were getting 8 CCs start getting 4 CCs. The ones that were getting 4 CCs start getting 2 CCs. So that way you will start to increase your PDCCH capacity, and the PDCCH congestion will start to decrease. Now we cannot make our PDCCH link adaptation very aggressive, because that means that the users might be unable to decode PDCCH, and in that case it will be counterproductive. So you have to tune it very slightly in a way that you can improve your PDCCH congestion. Now normally when it happens, that means that you have too many small packet users, because if let's say I have 6 users and all of them are carrying let's say watching YouTube, so that means that they have lots of data to download. So in that case they will have high number of PRB requirement. So we will not really hit the PDCCH, which we might hit the high PRB utilization, so we might hit the data congestion. But if users are, let's say there are 20 users and all of them are just using WhatsApp chat, so in that case they just need very small amount of data, but each user still needs a PDCCH grant, right? So this kind of information, this kind of traffic can trigger control channel congestion. So if you have small packet users, then you can trigger control channel congestion. If you have big packet users, then you can you can actually trigger data congestion. So this is just an indication, but you can't really change the profile easily, so it's just more of an information. Then if you have done all of that and still you are unable to do anything else, then you can try load balancing as well, so that if you shift users from one layer which has high control channel congestion to another layer which has higher bandwidth, and higher bandwidth means that you will have more PDCCH capacity. And another thing that you can do is that you can expand your PDCCH. For instance, if you're using one PDCCH symbol, you can expand it to two PDCCH symbols, which can also reduce your PDCCH utilization, but it will eat away your data resources. Now, this is just to show you an overall step-by-step view that for each kind of scenario, how you can identify using counters and KPIs, and then what can you do to resolve the issue. Now, there's one more problem that happens with throughputs. That is, let's say you have an issue coming from the backhaul. You can have congestion on the backhaul, you can have application level issues, you can have, let's say, a core issue, a core network issue, or you can have, let's say, a server level issue. So in that case, how can we identify with our KPIs? So for that one, stay tuned. My next video will cover how we can identify throughput issues that are not related to RAN using KPIs. Okay. I hope you like it. Thank you so much. Have a nice day.